All right. This is a PowerPoint that I will go through. We went through it in class just on basic energy. We're talking about mechanical energy here. There's lots of different energy forms that we can talk about: chemical energy, heat, light, sound, etc., etc. But in this, we're mostly just talking about mechanical energy, talking about potential gravitational energy and energy of motion, kinetic energy. All right. Energy can be defined as the ability to produce change in an environment. I talked about the example with the book going across the desk in class. That is definitely a change in the environment. The book has changed positions. Energy can also be defined as the ability to do work. If I push the book across the table, I am doing work on the book. I'm applying a force and I'm moving at a certain distance, and so that does work on the book. And the only way to do that work is if I have some energy. I actually have some energy to apply the force to do the work. And it's very important that you know that energy is measured in joules just like work. And that's a very, very important point because energy and work are very closely related. So energy and joules is very closely related. Work can also be defined as a transfer of energy. Two types of energy that we'll look at: kinetic energy and potential energy. Obviously, kinetic energy is energy of an object due to motion. Potential energy would be stored energy. And there are lots of different forms of kinetic energy, or potential energy rather. We're going to talk about the type that's stored when you're on the top of a cliff, that is gravitational potential energy. But you also have potential energy when you pull back a bowstring or a slingshot, when you jump on a trampoline. Those are called spring potential energy. When you pull those back, when you pull back a bowstring, if you let it go, it will move. It has the potential to move. Whereas in the shopping cart episode that I was talking about, the first day of class that we talked about energy, if you push on a shopping cart and it doesn't move, when you let go, the cart's not going to move. In other words, you have given it no potential energy just because you applied a force. There's also some potential energy in the food that you eat, in your lunch, in the form of kinetic or chemical potential energy. The starches, the sugars that are in that lunch go into providing energy for your body. There's some potential stored energy there. So first I want to look at kinetic energy. Again, it's the energy of motion, and we can calculate kinetic energy using this equation: 1/2 mv squared. 1/2 m would be the mass in kilograms, v would be speed, meters per second. 1/2 mv squared. Notice that kinetic energy depends on both mass and speed. And the question posed in class was, which would you rather have hit you in a head-on collision, a Ford Focus or a semi-truck? And the answer is, of course, the Ford Focus. And the reason is because of mass. It has less mass. If they're both going the same velocity, you want the one that has less mass to hit you, because less mass translates into less kinetic energy, and that means less energy will be transferred to you, and it'll be more likely you'll make it through the collision. Kinetic energy. And then we have gravitational potential energy. Gravitational potential energy is symbolized by U sub G. The letter U is the letter that we use to denote any potential energy, but U sub G is specifically gravitational potential energy. And gravitational potential energy is symbolized by mgh, mass times gravity times height. So here we have gravitational potential energy, again measured in joules, just like kinetic energy was. Mass is still in kilograms. G is the acceleration due to gravity, which is 9.8 meters per second squared. And h would be the height above the ground. So anytime you have some height, you are located some distance above the Earth's surface, you have gravitational potential energy. And you might notice that this mg right here might look familiar to you. That's because weight equals mass times gravity. So really the potential energy, all that is your weight multiplied by the height you are above the Earth's surface.